In algebra, we really spend a lot of time in doing detailed analysis of the problems that we look at. So when we look at a word problem, we don't just want to know what the answer is. We want to know every single part of the question. We want to understand completely every piece of it. So when we solve word problems in algebra, the first thing we always do, well, we start by, we define our variables and write an equation. Now I call this step 1, even though it's two things, because there are some people who, and I don't know why this is, some people have to define their variables before they write their equation. So they have to say x equals this, y equals this, okay, now I can write the equation. Some people, like myself, I don't know what it is, but I can't write the equation first. I can't define the variables first. I have to write the equation first. Once I write the equation, then I can define the variables. The equation just comes to me, and then I have to define the variables afterwards. All that matters is these are the first things you do. First, you define your variables and write an equation. Once you've done that, you have to decide your data type. Okay. The third thing you do is you decide what your appropriate and reasonable list of data is going to look like. So you decide reasonable values. Okay, we've done some of this already, and we will do so much more of it. You won't even believe how tired you are of it. We did, and this is what we're doing today. We're going to do this tomorrow. But for today, we're going to decide about data types. There are two data types. They are called discrete and continuous. Now, discrete and continuous are two concepts that you will, these are tricky concepts. You really have to think about them, and there's a lot of interpretation. As I saw when I saw you guys doing your homework today, a lot of you were like, well, what about this? Well, what about this? So it's going to take practice before you get really good at it. Don't be discouraged if you kind of struggle with it at the beginning. I'm going to do the same lessons that we did today, the same examples. So when we look at discrete data, I gave you like a bunch of definitions that had a whole lot of big words that didn't really mean a lot. I'm going to be honest with you. Set of data is said to be discrete if the values belonging to the set are distinct. Okay, here's the really important part. Discrete data is counted. And when you decide whether data is discrete, the question you ask yourself is, can I have half? Okay, can I have part of one? Okay, so let's take a look at that. When I look at these, CDs, can I buy part of a CD? No, I sure can't. Can I have like half of a penny? No. Can I take a dollar bill and tear it in half? No, I can't do that. I could have 50 cents, but money, physical money, counting physical money, that is discrete data. Jelly beans, yeah, I can bite a jelly bean in half, but can I buy half a jelly bean? Probably not. Tickets. So if I go to the movies and I buy movie tickets and I decide halfway through I don't want to see the movie anymore, I can't just go back and say, yeah, you know what, I only want half of this ticket, give me back the other half. I can't buy a song and think, you know, I don't like the whole song, I only like the second half, so, you know, I'm just going to buy half the song. They won't sell it to me, okay? So when we think of discrete data has to be specific size. Okay, it has to be a specific size. So maybe it has to be one CD or one ticket or a 5-pound bag of potatoes or a 1-pound bag of carrots. If I go to the store and I want to buy a loaf of bread, I can't say, you know what, I really don't want the whole loaf of bread, I only want to buy 2 pieces. I can't do that. I have to buy it as a whole loaf. Okay, so I hope you understand. I hope I've made enough examples for you to get it. This is an example, and we will actually use this same example tomorrow when we talk about domain and range, which is our reasonable list of values. So in this case, Marcus wants to buy some new CDs. The CDs are on sale at the store for $12 each. There are 5 CDs Marcus would like to purchase. He also plans on purchasing a holder for the CDs, which is on sale for $5. Again, I recognize that this is clearly a problem from the long ago. Old man Marcus is buying CDs. I know somebody in 7th period suggested maybe he was buying VHS or 8-tracks, but he's buying CDs and they're not that old. Don't be mean. Okay, so before Marcus buys a single CD, before he buys a single CD, he has spent $5 on the CD holder, okay? And then after he buys one CD, he's up to $17 for the CD and the CD holder. When he buys a second CD, he's at $29. When he buys a third CD, he's at $41. He buys the fourth CD, he's at $53. And he buys the fifth CD, and that's $65. And Marcus says he's only buying 5 CDs. So at this point, I stop plotting points because this is all the data that I need to plot. Now, when we talk about data types, the reason we've actually kind of gone ahead a little bit anyway, because the reason we talk about data types and we talk about what the data type is, because the data type tells me what my graph is going to look like. So the data type kind of informs me what my visual what my visual representation is going to look like. So if I think about this, if I were to draw a line between these two values, I'd be saying that Marcus can buy 1.5 CDs, and he's going to pay like about $25 for it. Can Marcus buy 1.5 CDs? No, he can't. He has to buy whole CDs. So we can't connect those lines. When I graph data, I'm saying this data, I'm like almost like I'm putting my stamp on it. I'm certifying it and saying this data, every point that I have listed, every point of data that I have put on this paper is a piece of data that is appropriate for the situation I'm looking at. And if I connect this line and I say 1.5 CDs is going to cost me like $23 or whatever it is, I'm wrong. So I cannot connect these points because the only values that are okay are 5, what is this, 17, 29. These are the only values that are acceptable, okay? And that's what discrete data is all about. It's about specific sizes of data. Now, when we refer to continuous data, again, we had this crazy definition up today. Data is said to be continuous if the values belonging to the set can take any value within a finite or infinite interval. Wow, that's a mouthful. Here, let's look at that. Continuous data can be measured. That's what we talk about. And in the graph, the points are connected because every point has meaning. So let's look at some continuous data. Time, temperature, speed, distance, volume. When I look at continuous data, I almost think of continuous data like it goes on between. This is such a hard concept to explain. But let's think about time. If let's pretend I'm driving my car home. I live about 3 miles away, and I usually go about 50 miles an hour, which is probably about 5 miles an hour faster than I should be going. Let's pretend I'm going 60 miles an hour, just because it's easy to calculate, and it takes me, and I live let's say 3 miles away. Okay, so here's what discrete data would look like if I was going a mile a minute. Okay, I would start at Truett, and I would just get in my car, and I would sit there for a whole minute. And then at the end of that minute, I would magically, whoosh, I would appear 1 mile away. I'd be at 0 miles. I'd appear 1 mile away from school. 0, 1. And then I'd sit there for another minute, texting or whatever. We don't text while we drive, but in this case, I'm not actually driving. The car's just teleporting. And then, whoosh, 1 minute later, I'd appear. I just appear a mile down the road. And then, whoosh, I just appear in my garage. Is that how travel works? No. I start here and I move, and at any point in between, I might have gone like a half a minute, then I'm a half a mile away. If I went like 1.36 minutes, then I'm gone 1.36 miles away, okay? So continuous data means that between the start and end point, every value in between is valid. And continuous data is stuff that I measure. So time doesn't jump. Temperature doesn't like boom, all of a sudden, even though it feels sometimes like we come into school in the morning and it's cold and then we leave at night and it's hot, that temperature rose gradually over the day. Speed, how fast I'm going is something that I measure. Distance I measure with, like height. I measure all of those things. And all of those things can be anywhere in between. So let's take a look at this. A water tank that can hold, let's say actually 65 gallons of water is being filled at a rate of 12 gallons per hour. The tank started with 5 gallons of water. The amount of water in the barrel after X hours is found by the equation 5 plus 12x. Now, this is the exact same data as the one that we just did, okay? So at 0, it started with 5 gallons, and then after an hour, it had 17 gallons in it, and after another hour, it had 29. After another hour, it had 41. After another hour, it had 53. And then after another hour, it had 65. And the tank can only hold 65 gallons, so I stop right there. Now, do I have to fill for 5 hours? No, I can stop anytime. Do I have to fill the thing all the way full? No, I can go for part of this time. I can go for part of these gallons. And because of that, I can connect the line. Now, I don't put an arrow on the end of it because the data stops here. If I fill any more water in the tank, it just starts overflowing. Okay? So, again, when we talk about our two data types, we have discrete and continuous. So, here's our discrete data, which is, old man Marcus buying CDs. And the discrete data is dots. So, discrete dots, okay, count. All right, so discrete data is graphed as dots, and we have to count it. Continuous data is connected, and we measure it.